Hello everyone. Plan for this recording, we're going to talk through solving quadratic equations. On the screen I have listed, I don't want to say the only 5, but the main 5 ways of solving a quadratic equation. First way we could solve it is by graphing. Not a great way unless you're using a graphing calculator of some kind or a computer graphing software of some kind where you can graph it very accurately and use the calculator to solve it, but I'm not going to focus on that one today. But the other 4 ways, we can take square roots, we could factor it, we could complete the square, and we could use the quadratic formula. Those are all very legitimate, nice, sometimes messy, ways of solving a quadratic. So let me quickly just look at each. We could take square roots. What does that mean? What if I had something really easy, like x squared equals 25? I could take the square root of both sides and get x equals plus or minus 5. And that could look a little messier, like x squared, or x minus 2 squared equals 25. And I could solve that by taking the square root, and I could get x minus 2 then equals plus or minus 5 and solve. Okay, so that's taking square roots. I could factor. What if I had something like this? X squared minus 5x plus 4 equals 0. I could factor that. X minus 4 times x minus 1 equals 0. And I could factor that thing. Then I could find out what makes each factor equal to 0. I could complete the square. Remember that from somewhere? I'm not going to use the completing the square. I don't find that to be the most effective way of solving because really, if you've watched my other recordings, when you complete the square, what do you generate? You generate the quadratic formula. So I'm not going to, I won't say ever, very, very rarely will I ever use the completing the square technique to solve a quadratic because the quadratic formula is already the outcome of the completing the square. So remember the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And we generated that from the completing the square of our basic quadratic formula, or a quadratic equation. So I'm going to solve the exact same equation I have right here so we can see we get the same answers. So x equals negative b. Well, my coefficient of x squared is a, my coefficient of x is b, and my constant is c. So negative b is a negative negative 5, plus or minus the square root of b squared, which is 25, minus 4 times a times c all over 2a. And from there we get 5 plus or minus the square root of 9 over 2, which equals 5 plus or minus 3 over 2. And 5 plus 3 is 8 over 2, which is 4. 5 minus 3 is 2 over 2, which is 1. And we get the exact same answer as above. So there's 5 techniques. Of those 5, I'm really going to use just 3 of them. Again, completing the square is a great technique, but it generates the quadratic formula, and so I usually won't do that. I don't say never. I usually don't use the completing the square, but I will rarely use a graphing technique unless my graph is given, or unless it's a nice, neat graph, or unless I just want an estimate. Okay? But we're going to focus on these 3. So from here on out in this recording, I'm going to simply throw you problems. You hit pause, give them a try, come back, and see how you did. These should be techniques that we know. It is simply now a matter of practice. So this recording, the section in this textbook for this class is simply reviewing, practicing how to solve quadratic equations. Okay. Try the question, or the x squared minus 7x plus 6. Give it a try. Hit pause, come back when you're done. Okay. What technique did you pick? When you look at that, do you automatically jump to quadratic formula? Try not to. That is a quick, simple factoring. I can factor that into x minus 6 times x minus 1. Why? Because 6 times 1 is 6, and 6 plus 1 is 7. How do I know I'm adding? Because this is positive. How do I know both terms are negative? Because that's negative. My answer, x equals 6, x equals 1. If you did the quadratic formula, you still should have got 6 and 1. But my guess is it took you a little bit longer than what it took to do the factoring technique. Okay, try the next one. You pick the technique and try it. All right. Hopefully you did not pick quadratic formula. That would be a pain. Hopefully you did not factor. That would also be equally a pain. Why? Because remember when we have, or when we factor, and when we complete the square, my equation must be set equal to 0, and it must be in the form ax squared plus bx plus c, kind of like the one we had above. In order to use a quadratic formula or factoring, it's got to be in that form. This one isn't even close. It has this single x squared term. When I have something like that, when I have one term that has an x in it, that's being squared, I simply isolate that squared term. There's no other x's. I can isolate that term. And then I'm going to take the square root. So my first step would be to add 7. Divide by 2. Take the square root. And add 2. Work it out because I can. So I go 2 plus 3. 2 minus 3. And I have my 2 solutions. Okay, next one. All right, what I notice here, I have both an x squared and an x. I can't do what I just did in the problem above. I can't isolate the squared term. So I need to use either factoring or quadratic formula, but in order to do that, it has to be set equal to 0. So that's my first goal. Leave the 4x squared alone. Subtract 2x gives me a negative 9x. Add 9, and I get a minus 3. Sorry, I got a little dot there I don't want. All right, I have an equation set equal to 0. I can now either complete the square, which would be a mess, or I could factor it, which it might, or I could quadratic formula, which it will. I would take like 30 seconds and see if you can factor it, maybe a minute, depending upon how good you are at factoring. And if you can't, I would jump to quadratic formula. Quadratic formula always works. Sometimes it's a pain to get it into standard form like it is right now so that I can use the quadratic formula. So sometimes we choose to take the square root instead, like the problem above it. But the quadratic formula, when it's set up correctly, will always work. Factoring sometimes works. Sometimes quadratic equations are not factorable. All right, so my guess is we want to jump right into quadratic formula. But, I don't know, you want to try factoring for a second? Let's try factoring. So my factors of 4x squared are 4x and x. Factors of 3 are 3 and 1. So let's try a 3 here and a 1 here. I get 12 and 1. 12 and 1 does not give me 9. It gives me 11. So let's switch. Let's put a 3 here and a 1 here. And I get 4 and 3. Again, it doesn't give me 9. So let's change that 4x to a 2x and a 2x. Factors of 3 are 3 and 1. Again, I'm subtracting because that's negative, and I don't get 9. All right, so we tried. Did it waste a lot of time? No. Did it waste some time? Yeah. But sometimes you're going to find, like question 1, if I were to jump right into quadratic formula, I would have wasted a lot of time when factoring gave me the answer nice and neatly. Okay, quad form. Negative b. plus or minus the square root of b squared minus 4 times a times c all over 2a. My guess is if you did this problem ahead of time, or ahead of me, that this is the most common place of making a mistake. If you have a negative 81 there, you typed something into the calculator wrong. You went a negative 9 squared. That is not what we have. We have a negative 9 squared. This is going to be a negative 81. This is going to be correct, a positive 81. We are squaring the entire term, negative 9. All right. Next step, let's reduce that mess inside. So I get 9 plus or minus the square root of 81. We can type it in the calculator. So I have 81 minus 4 times a negative 3. And I get 129. Whoops, wrong color. All over 8. Next, is there a perfect square that goes into 129? I don't think so. So we're done. If you're going to the nearest hundredths, you just grab a calculator, type in 9 plus square root of 129 divided by 8, and 9 minus. All right, so there's some of the practice problems. This one I want to show you, this is kind of a little trick. We could multiply all that out. We could FOIL 2a plus 4 times 2a plus 4 and so on. Let me rewrite that some way, and you see if you can see the pattern. If I were to subtract this as one term and then subtract that, does this not look like 6x squared minus x minus 2 equals 0? Doesn't that look just like a quadratic equation where we're calling 2a plus 4 x? It is 6 times something squared minus that same something minus 2. It is 6 times something squared minus that same something. That x and that x are the same thing. They are 2a plus 4. So really, this is a quadratic equation. And what we could do is just jump over here and say x equals 2a plus 4. So where I see 2a plus 4, I'm going to plug in x. Don't really need the parentheses anymore. So I have 6x squared minus x minus 2 equals 0. And go right back to your same techniques. I'm going to try factoring that. Factors of 6, 3 and 2. Factors of 2 are 2 and 1. One's a plus and one's a minus. I have 3 and 4. 3 minus 4 does give me the one that I want. I want a negative 1. So my 4 needs to be negative, and my 3 needs to be positive. So a negative 4 plus 3 gives me the negative 1 that I want. So I've factored this thing. So now what? Back from our factoring techniques. Then I know that 3x minus 2 needs to equal 0, so x needs to be 2 over 3. And 2x plus 1 needs to equal 0, so x needs to equal a negative 1 over 2, just using simple algebra to solve. Give myself some room here. Well, x isn't really x, and I don't see any x's in the original problem. There are no x's in this original problem. We did something over here. We called x 2a plus 4. So now I know what x is, so I can just solve that. 2/3 equals 2a plus 4. Solve for a. 2/3 minus 4. Get a common denominator. That becomes 2/3 minus 12/3, which equals a negative 10/3. Divide by 2, and a equals negative 5/3. little bit of fraction work there. Okay, so one answer, A equals a negative 5/3. Repeat the same process. Take the negative 1/2, stick it where x is at, and do it again. Negative 1/2 minus 4. Common denominator is a 2. And so I get negative 9/2 equals 2 over A. Divide by 2, and A equals a negative 9/4. And I get my two answers. All right, next question. Do you see the same pattern in this problem here? Take a look at that problem there. See if you can use the same trick and set it up to be x squared minus something x plus or minus something equals 0. All right, here's your trick. This term right there determines x. This term right here determines x, or this term right here. So what is x? In this case, I'm going to call x the square root of t. So now if x is the square root of t, then what is t? Well, if I square both sides, then x squared is equal to t. Right? Squaring this side, x squared is equal to t. All right, so substitute. T is x squared. Get my pen back up. Minus 3 times x minus 10 equals 0. And I'm right back to solving a simple quadratic equation. I'm going to factor this thing. X minus 5 times x plus 2. So x needs to equal 5, or x needs to equal a negative 2. Go back over to what x is. X is the square root of t. So plug in 5. The square root of what number equals 5? Square both sides. And t is 25. Or the square of what number equals, square root of what number equals a negative 2. And don't do this. Oh, t equals 4. Is the square root of 4 negative 2? No. Simply squaring both sides, you have to be careful, because the square root of 4 is not a negative 2. You can't square root a number and get a negative. Not possible. So the only answer is t equals 25. Notice I don't use x equals 5. That's not my answer. There are no x's in my original problem. The answer is t equals 25. You want to plug it in to make sure? Let's plug in t equals 25 into that. So I get 25 minus 3 times the square root of 25 minus 10, and that should give me 0. I get 25 minus 3 times 5, right? The square root of 25 is 5, gives me 15 minus 10 does equal 0. All right, last one. Give it a try. Use the same logic. What are you going to replace x to the fourth with? Let me help. Let me get rid of the x's. Let's make these t's. So you can use x as your variable. Let's call this t's. Okay? Give it a try. All right. Using the thought process I had before, I'm going to make t squared equal to x. And so t to the fourth is going to be x squared. Plugging things in, I get 2x squared minus x minus 3 equals 0. Factor, I get 2x and x. Excuse me, minus 3 plus 1. Factors that thing down. And I get x equals 3 halves, and x equals a negative 1. X equals 3 halves, because 2x minus 3 equal to 0, solve for x equals 3 halves, and a negative 1. Go back here to x. Negative 1 needs to equal something squared. or something squared equals a negative 1. Your first thought might be, oh, if we square something, it'll never be negative. Be careful with that. You can't square a real number and make it negative, but you can square an imaginary number and make it negative. So in this case, t equals plus and minus the square root of a negative 1. By definition, remember, the square root of a negative 1 is I. So one answer is t equals plus or minus I. Next one. Same logic. X equals 3/2. So 3/2 needs to be t squared. Let me grab this and slide it over here. So we get plus or minus the square root of 3/2 equals t, square rooting both sides. And when you have a fraction inside, we have to split that into its two parts. I cannot have a square root on the bottom, so I multiply top and bottom by the square root of 2. And the square root of 2 times the square root of 3 is the square root of 6. And on bottom, the square root of 2 times the square root of 2 is just plain old 2. And so I get t equals that and t equals that. We get 4 solutions. Okay. I hope that helped. Give them some practice problems to try.